Good morning student. In the previous lecture we have studied the design procedure of Muff coupling. Now in this lecture we will take numerical problem on Muff coupling. Design a Muff coupling for connecting two shafts transmitting 50 kilowatt at 450 rpm. The material for the shaft and key is same, for which allowable shearing and crushing stresses are 40 megapascal and 80 megapascal respectively. Now first of all we write the given data. Power is equal to 50 kilowatt, that is 50 into 10 raised to 3 watt. RPM, N is equal to 450 RPM, and tau is equal to 40 Newton per mm square. Sigma Ck is equal to 80 Newton per. This is the sectional view of the Muff coupling. This is key, this is sleeve, this is shaft. Outer diameter is capital D, length of the sleeve is L, and diameter of shaft is D. Now first step is determination of shaft diameter considering in pure torsion. We will calculate the power or torque required or torque to be transmitted by the formula P is equal to 2 pi n upon 60. We will calculate the torque. Then after calculating the torque by the formula T is equal to pi by 16 tau d cube, we will calculate the diameter of the shaft. We will calculate the torque by putting the values of power 50 into 10 raised to 3 and N is equal to 450. Now torque comes out to be 1061.03 Newton meter. We will convert this into Newton millimeter by multiplying by 10 raised to 3. This is Newton millimeter. Now from this formula T is equal to pi by 16 tau d cube, we will calculate the diameter by putting the value of torque and permissible shear stresses. Now diameter comes out to be 51.31 millimeter. Say we take the 52 millimeter. Second step, design of sleeve. From usual proportions, capital D is equal to 2D plus 13. Putting the value of shaft diameter, the outer diameter of the sleeve comes out to be 117 millimeter, and length of the sleeve, that is 3.5 times the diameter. Putting the value of shaft diameter, the length of the sleeve comes out to be 182 millimeter, and the ratio of K, that is small d upon capital D, that comes out to be 0.444. Now we will check the dimensions of the sleeve considering the sleeve as hollow shaft. Now applying this formula, T torque is equal to pi by 16 tau induced into D cube in the bracket 1 minus k raised to 4. From this formula we will calculate the tau induced. Now putting the value of torque and outer diameter of the shaft and K, we will calculate the tau induced. That comes out to be 3.51 Newton millimeter square, which is lesser than the tau permissible, that is equal to 40 Newton per mm square, that is given. Hence the design of or the dimensions of the sleeve are safe. Design of key. From usual proportions, W is equal to D by 4. D is equal to 52. So putting the value of shaft diameter 52, the width of the key comes out to be 13 millimeter and T thickness comes out to be 8.67 millimeter, and the length of the key, that is equal to the half the length of the sleeve, that is equal to comes out to be 91 millimeter. Checking the dimensions of key for shear stresses. Now the torque is equal to L into W into tau induced into D by 2. Putting the values of torque, length, the width and diameter, the tau induced comes out to be 34.49 Newton per mm square, that is lesser than tau permissible, that is equal to 40 Newton per mm square. Hence it is safe in shear. Now we will check the dimensions of key for crushing. We have the equation T is equal to L into T by 2 into sigma Ck induced multiplied by D by 2. Putting the value of torque, length and thickness and diameter, we will calculate the sigma Ck induced. The value of sigma Ck induced comes out to be 103.47 Newton per mm square, which is greater than the sigma permissible given 80 Newton per mm square. Hence, dimensions are unsafe in crushing. Now we will recalculate the length by considering in crushing. The new length is calculated by this equation. Torque is equal to L into T by 2 into sigma Ck multiplied by D by 2. Putting the value of torque, thickness, sigma Ck and diameter, we will calculate the new length. That comes out to be 117.67 millimeter. Say we will take 118 millimeter, and the new length of the sleeve, that is L, is equal to twice the length of the key. That comes out to be 236 millimeter. These are the final dimension. Diameter of the shaft is 52 millimeter. Capital D, outer diameter of the sleeve 117 millimeter. W, width of the key 13 millimeter, thickness of key equal to 8.67 millimeter, length of the key 118 millimeter, and length of the sleeve 236 millimeter. So this is all about the design of sleeve or muff coupling. Thank you very much. We will meet in next session.